let's wrap up 11.2 here. So the last couple of things we have to do is Venn diagrams and combinations. So on this example, it says we've got 147 students that were polled. 95 of them liked softball, 73 of them liked football, and 52 liked both. And we need to display these results in a Venn diagram. So when we are looking at these numbers, we need to first figure out what categories we have in our Venn diagram. So it looks like we've got softball, we've got football, and we've got both. So it looks like I'm going to need two circles, because in a Venn diagram we've got circles. So pretend those look good. It looks like the first circle we have softball, and in the other circle we've got football, and in the middle there will be people who liked both. So how many people were there that liked both? Well, there's 52. 52 people that liked both. So now I have a question for you. Out of these 95 who liked softball, can I put 95 in the circle? I can't, because of those 95, 52 of them liked both. So it's not 95 that like only softball, it's the remaining number of softball appreciators after I take my 52 away. So 95 minus 52 leaves me with 43 students who liked just softball. Same thing with football. I have 73 who like football overall, 52 like both, so how many do I find, how would I find the number that just like football? Well, I'd take my 73 and I would subtract 52, and I would get 21 that just like football. Okay, so I've got some that like softball, some that like football, and some that like both. But probably I'm going to have some that don't like either one of those. So how am I going to find that? Well, I'm going to take my 147 total and subtract these numbers. And I would get 31 students who don't like any of the above. So then our question says, what is the probability that a student likes softball or football or both? So since I'm kind of running low on room, I'm just going to say probability of softball or football or both. So remember from our others, the word or means that we are going to be adding these probabilities. So the probability that they like softball plus the probability they like football plus the probability that they like both. Well, how many liked softball? Softball had 43 out of our 147 students. Football had, just football, had 21 out of our 147 students. And then both had 52 out of our 147 students. So if I add those all up, I get 116 out of 147 students. Now, it may want it as a fraction, or it may want it as a decimal, or it may want it as a percent. Make sure you're reading the directions to see how your answer needs to be noted. Now in 11.1 we learned about combinations. Remember, they can be used to find the number of outcomes for theoretical probability, so when each thing is equally likely. So what is the probability that I would choose exactly 2 girls to make a group of 5 students if a class has 8 girls and 7 boys? Well, what would I need? I would need to choose 2 girls out of, how many girls are there? And in that group, so I need 2 girls, but to make up a group of 5 students, I need 3 more students, and what would those students have to be? They would have to be boys. So we would need 2 girls, and we would also need to choose 3 boys out of the 7 boys that exist in this class, in this fictional class that has 8 girls and 7 boys. And then we would need to divide that by a choice of 5 students out of 15 students. Okay, because I want it to be exactly 2 girls, and we would need it to be exactly 3 boys, and probability is what we want divided by the total of what's going on. So we're choosing 5 students out of our 15. So since we are grouping and the order doesn't matter, we are going to use combinations. So 2 out of 8, so I have 8 total, C for a combination, and 2. Then and, do you remember what operation and means? And, probably should have used a different color, and means we are going to, multiply. I almost put add. And is multiply. I feel like it's tough because when I see and it has the first and last letter as add, I want to add, but it's not, it's multiply. Then this one I have 7 total students and 3 of them I want to choose. And then in my denominator I've got 15 and 5. Because I've got 15 total students and I'm choosing 5 of them. So here, 8C2, I've already done the math. If you don't remember how to do the math, you can refer back to the 11.1 video. But I've got 28 times 35 divided by 2002. I should just go ahead and show you how to do that math, because we've only seen it once. So 8C2, we would do 8 factorial divided by 8 minus 2, 6 factorial times this number, 2 factorial. And there is a factorial button in your calculator, and that would give us 28. And then 7C3, we would do 7 factorial divided by 7 minus 3, so 4 factorial divided by 3 factorial, and that's what gives us 35. And then 15C5, we would do 15 factorial divided by 15 minus 5, so I'm doing that in the wrong order. Oh well. 10 factorial and 5 factorial. I switched these on all of those, didn't I, from your formula, but that's okay, it'll still give us the same. Okay, so 28, 35, and 2002, that's how we get those. So that if I multiply and divide, I would get 0.4895, or 48.95%. So there is a 48.95% probability that a group chosen from this specific class would be exactly 2 girls and 3 boys. Okay, last example from 11.2. A group of 20 OHS students are at the movies. There are 110 people in the theater. The owner is going to choose 10 people to receive lifetime movie passes. What is the theoretical probability that, exactly 5 of the 10 chosen are OHS students? Okay, so we want exactly 5 of the 10 chosen. So first, how many do we want? We need so we're going to do success, or what we want, over total. So total may be easier. So how many passes are getting chosen? 10. 10 passes are getting chosen. And how many people are in the theater? 110 people are in the theater. So we are going to choose 10 out of the 110. That looks terrible. So we want exactly 5 of them to be the OHS students. So 5 of them out of how many there are OHS students. So what's the total number of OHS students? 20. And our other ones, if 5 of these total 10 passes are OHS students, then the other 5, okay, so this is going to take a little bit of work. So there's 110 total students, 20 of them are OHS students. So this group is going to be non-OHS moviegoers. So how many of our 110 people are non-OHS? So we take 110 minus 20, and that would give us 90. So we would have our total 20 C5, and means we're going to multiply 90 C5 divided by 110 C10. Ugh, it's going to be fun. Okay, so 20 C5. So we would have 20 factorial divided by 20 minus 5 is 15 factorial times 5 factorial. So okay, and then the 15, etc. would cancel with that, but we'd still have 5 times 4 times 3 times 2 times 1. So this is going to be, fraction bar. Okay, so make sure you're doing this multiplication to get this big number and this multiplication to get this big number before you divide them. So that gives me, if I divided that right, 15,504. And now I need to do, I have a feeling these are going to get really big, and I have a feeling I didn't leave myself enough space. Well, we do what we can. 90 C, what is this, 5, oh gosh, 90 factorial over 85 factorial times 5 factorial. So 90, 89, 88, 87, 86, 85, there's where it's going to start to cancel with this 85 dot 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 dot. That'll cancel with that one. Then I've got 5, 4, 3, 2, 1. Oh hey, that's handy, I already did that. 5, 4, 3, 2, 1, I know from that above one is 1,020, or 120. This though, is going to be a really big number. Oh gosh. 5, 2, 7, 3, 9, 1, 2, 1, 6, 0. So now that I found that really big number, I'll divide it by 120. And 4394928. Nice. So and means multiply, so we're going to multiply that by 43,949,268. Hopefully this denominator number is pretty big so we can get some stuff out of here. Down here I have 110 C10. So 110 divided by 100 over and 5. So 110, 109, 108, 7, 6, 105. I haven't got to the canceling yet. $100, there it is. That cancels with this 100, and I still have 5, 4, 3, 2, and 1. Oh my gracious, this is going to be a big number. It's probably going to give it to me, yep, in scientific notation. So 1.7018, and then it may, your calculator may say E. That just means times 10 to the, and then whatever number it says after E. So this means I would need to move my decimal place 20 places to the right if I wanted to actually write that number out. Oh my goodness, I made a mistake, didn't I? That one says 10, so this needs to be 10 factorial. So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Sorry about that. At least I caught it. So this is going to divide by 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. If we multiply all of those together, 36, 2, 8, 8, oh. So this is going to give me 4.6897636662 times 10 to the, I don't know. .7018 times 10 to the 20th divided by 3628800. 10 to the 13th. Oh, that's going to be fun. So when I write this, I'm going to stop writing it. That said 13th, not 10th, Mrs. Black. I'm going to not write it in scientific notation. So it's going to be 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9. So I need 1, 2, 3 more zeros. Nope, 10, 9, 10, 11, 12, 13. There we go, 4 more zeros. So 4, 6, 8, 9, 7, 6, 3, 6, 6, 2. Where did I mess up? Zero, 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 zero. Blech. That's gross. Okay, so this should give me 0.0145 or 1.45%. But I may have messed up somewhere in calculating this number, and if I did, please find that mistake and let me know. I also want to talk to you really quickly about how else your results can be displayed. Your results can be displayed in a bar graph. So like on this one, for example, if I wanted to figure out what was the probability of getting a C, my success would be 6 over, and then I would have to add these all up. Same thing here. Let's pretend I wanted to get this one. I would have 10 over, and then I would have to add all those up. Okay, so your results can be represented in pictures rather than given to you in word problems. So watch out for those as you're doing your assignment.